Last lesson of the chapter, baby, solving proportions. A proportion is two fractions that are just set equal to each other. So there's a fraction, there's a fraction. But you might go, well, how is that any different than what we just did last time? Can you see this dude right here that I put in the green box? Even though there's a fraction right here and there's a fraction right here, there's some other like term being added or subtracted to it. You know, it's not truly a fraction in that case. There's a fraction and another term. So in the green box is not a proportion. But over here, this is it. It's a fraction equal to another fraction. And there are many ways to solve a proportion. I think you would enjoy the fastest way to do it is do something called this. Do you know what I'm even going to say? Cross multiply, right? To cross multiply, maybe your teacher in the past has called it means and extremes. I'm not a big believer in calling it that because it's like which ones are the means and which ones are the extremes. Who cares? I'm going to take this dude times this dude, and I'm going to take that dude times that dude, and it doesn't matter what order you do it in. So I'm going to do 5 times 27. Forgot to get my calculator open. Could you punch that in for me while I'm getting my calculator open? What is 5 times 27? 135. Here's a big deal, though. You've got to bring an equal sign down, right? The equal sign needs to come down, and then I'm going to do it times a times 15. How would you like me to write that, though? 15a. Are you cool with just cross multiplication process in that situation? Then we just solve that for a. Let's get rid of that times 15 by dividing both sides by 15. And it may or may not come out nice, man, you know. Did this one come out nice? A turned out to be how much? 9. Be prepared on your homework for them to not come out nice. They will be very fractional. So that was a basic boy, right? What makes the next few different is because do you see in one of the denominators they have more than one term, like there's an a minus 4 or something like that. Do your brain a huge favor and throw those in parentheses. Those are called binomials. You may have heard that. Bi means 2. Nomial means term, you know, so there's 2 terms in that situation. And we do the same thing. We cross multiply. But man, do people have a hard time with some of that. 7 times 5, what you got? Equals. Watch this move. I got to take 14 times that whole parenthesis. So I'm going to write it down like that. 14 times that whole parenthesis. And guess what I need to do with this 14? What's that called? We got to distribute the 14. So 35's coming down. 14 times a is 14a. And then I do my sign next. I got a positive times a negative, so that's going to be negative. And you can punch in 14 times 4. Like I said, calculators are awesome. They're there to make our lives faster. Basic arithmetic, we probably don't need a calculator. But this is more than basic arithmetic. It's all right, 14 times 4. I'm going to just punch that in. It's cool with me if you got to punch that in. What's my next move right here? I want to get a all by itself. I need to do what? Let's add that 56 over, man. So again, if you don't want to show the baby steps, you don't have to. I'm still doing it for the benefit of those who need it a little bit. When we add those together, and I get a 91 is what I got. Is that what you got as well? And then there is still 14a over there. And my move is to divide by 14, right? And now I'd like to show you a trick if you have a graphing calculator like mine. Sorry, I thought I hit that graphing calculator. There it is. For those of you who have one of those little baby calculators, you probably have fraction buttons and know where your fraction buttons are at, right? But if you have a big graphing calculator like mine, I want to show you a trick since we're in advanced class. I want to do 94 divided by 14, right? You know, that's definitely not coming out nice. But 94 14ths as a fraction could probably reduce. So how I reduce it with one of these bad boys, it's a key sequence that we call math enter enter. There is a button over here. Like you see this, it's hard to see my little cursor because it's so small, but let me just do this. Okay, what's everybody looking at? Did I make a mistake? I could have. Did I type the wrong thing in? 91 14ths? Oh, I did 94 14. So you got to tell me that, right? You know, it's like I knew I made a mistake. It should be 13 halves, right? You know what I mean? So it's like something happened. So hey there, video people, I typed the wrong thing in. It's 91 divided by 14. And then if you do math, enter, enter. Your homework won't accept 6.5 today. I went in and like programmed it to not accept 6.5. You got to change it to a fraction. 13 halves. How's that sound? That sound better to y'all? Thank you for correcting me. Everybody makes mistakes. Just learn to fix them. So let's do one more. Let's throw parentheses around this binomial right here, and let's solve this proportion by cross multiplication. So doesn't matter what order. 1 times that parenthesis, I don't even need to write the parentheses. 1 times anything is going to turn out to be what you got. So like 1 times y plus 6 is just y plus 6. And 4 times 2 is 8. So then I will subtract 6. Did you get y equaling 2 on that dude? That one came out real nice. All right, here's another proportion. We're going to cross multiply. So, boom. And let's see what you got. Why don't you pause the video and set it up and check it with mine. So there's my setup. And now I want to distribute the 5 through. And the equals 24 comes down. Right? And then I will add 5 to both sides. And that's 29 right there. And then I want to divide both sides by 5. And that's not going to come out nice. I can check to see if 29/5 reduces in my calculator by doing 29 divided by 5 and hitting math, enter, enter on this guy, and it does not reduce. It's 29/5, you know. So if you got that right, keep going, man. Let's get through 6. Just keep on working with a neighbor. So I threw all these bad boys in parentheses, and I cross-multiplied. That's my setup. And now I will continue. So, boom. And then we need to do what? The other mistake that we make is this move. What's wrong with this? That's wrong. What's wrong with that? You need to add 14 to both sides. It happens to the best of us. 32. Hold on. Divide by 7, divide by 7. Is that going to come out nice? Does 32/7 reduce? Good. Hey, is the next one and the last one of these a proportion? Not really. Can you make it one? What could you do to that 2? I would do that. To me, that's a simple move. Put it over 1, you know, and now we could cross multiply. So 3 times 1 is 3, and throw parentheses around that bad boy. It's 2 times x minus 2 as a quantity. When they say quantity, if they ever say that on your homework, that means it's something in parentheses, like x minus 2 as a quantity. So 3 equals 2x minus 4, add 4, add 4, 7. My bad. Not too shabby, eh? It seems like you've kind of done it before also. Just watch the distribution part. Let's get to some story problems. I am 100% picky about how you do these story problems. I know there's many ways to do them. You're going to do them my way. Please trust me for the future of what your math life is going to look like. My way is the best way. So I ain't joking. Please read that story to yourself. The hardest part about knowing how to solve this, if they don't tell you, because this one told you, set up a proportion. But when you take the ACT, they don't give you like legit instructions, like please use a proportion to solve this. They just give you the story, and you've got to figure out how to solve it yourself. So how do I know I even want to do a proportion without them telling me to? Do they give us some sort of like rate that something happened at? Isn't Yolanda painting a room, correct? Do we know a rate that it happened at? Right here, baby. 400 square feet of wall space in 2.5 hours. Are you with me on that? That's like a rate that it happened. So here's the secret to success. We're going to set that up as a fraction with labels. And the labels are what I care about. So 400, what would be a label that could go on that? 400 what? Square feet. So that's like putting feet squared, you know, in that situation. For every, I'm totally cool if we change that 2 1/2 to a decimal. If it easily converts to a decimal, let's do that. So 2.5 hours. Are we okay with that? And to set up a proportion, here's where I'm also picky. You need to set up a complete new fraction with an equal bar in there. And to keep this thing, here's a magic word, proportional, the labels have to be in the same spot. If this is square feet over hours, this one has to be square feet over hours. And just telling you right now, there's 4 points on the test right there just for the labels. You need square feet over hours equals square feet over hours twice, right? You with me on that? Twice. But the labels make everything easy because then they then ask a question, hey, at this rate, how long will it take her to paint a room that has 720 square feet of wall space? It is no question where that 720 needs to go now. Should it go upstairs or downstairs? Because it's square feet. Are you with me on that? It goes right next to it, so we're going to do 720. And then the good question is, well, what should we put downstairs? Isn't that what they're asking us to find? We will put a variable there. That's what we don't know. What would you like to use for a variable? X would be awesome. I don't care what letter you use. I usually use X. You cool with how I set up that proportion? Awesome. How do you solve a proportion? Cross multiply. Forget the labels now. Labels are gone, right? Forget the labels. We're going to do 400 times X, which is 400X, equals 2.5 times 720. What does that punch out to be, baby? 2.5 times 720. Did we get 1800? Cool. And now let's solve for X by dividing both sides by 400. It could very likely not come out nice. Did this one come out pretty nice? 1800 divided by 400. Did it come out nice? Yes. So if I went math, enter, enter, that's 9 halves. Does 9 halves make sense for this story problem? It's like, how long did it take her? 9 halves hours. Or would 4.5 hours make more sense? In the real world, which number makes more sense? The decimal does, right? So fractions make sense sometimes for algebra problems. We're going to do 4.5. My bad. How did I know it was hours? That's so simple. It's right here. Isn't that the label that's next to X in your proportion? That's what you're doing. So it took her 4.5 hours. And yep, I'm a big label guy. You see there are 5 different labels in this problem. 1, 2, 3, 4, 5. You know, you got to do it in the final answer. So could you believe that if there was 3 of those on a test and you didn't put any labels, you just missed 15 points, even though you may have done all the math right? Please put the labels. Please put the labels. Let's try another one. This is a little more complicated. In an election, Mr. Smith beats Mr. Jones by a 3-to-2 ratio. If Mr. Jones got 6,500 votes, how many did Mr. Smith get? Let's look for that rate. Don't they give us like a rate in this situation right here? I'm not a colon guy. That's what those 2 dots are called, is a colon. Colons are hard to deal with in a math class. We are going to make that a fraction instead. So we're going to go 3 over 2. The problem is we don't have any labels on that. Discuss with your neighbor what you think the labels could possibly be. We decided that votes is not a good label because it'd be votes over votes. We want to put their names instead. So there's Smith and Jones. Hey man, how do you know where Smith goes and where Jones goes though? Where should Smith go? Let's put it that way. How do you know it's got to go up top? Because he won, right? And shouldn't he have gotten more votes, right? So we're going to do Smith over Jones. Good, good, good. Smith got more votes because he won, so set it up. If this one's Smith over Jones, this one's got to be Smith over Jones. And don't forget, I told you I know there's other ways to solve these problems. This is the way I'd like you to do it. So Mr. Jones got 6,500 votes. That means there's a no doubt that 6,500 is going downstairs because isn't that where Jones is located? So now let's put an X upstairs and solve this proportion by cross multiplication. 3 times 6,500 is 19,500. That will equal 2x. And then if you divide both sides by the 2, there's my math. What's the label that you want to put on it? We got to be a little more real lifey. You can't just put Smith. You know, I mean, I know that's what we put in our proportion, but they didn't get 97,500 Smiths. What's the 97,500 get? There's a lot of votes, right? We got to be more specific. Votes is in there. Votes for who? Yeah, you got to be specific with it. There was 97,500, excuse me, 9750. I said the wrong number earlier. 9750 votes for Smith, right? So nice and specific. Feel cool with that? Proportions are one of the most realistic things you'll ever do in a math class, just like this. A farmer is supposed to mix a pesticide in a ratio of 5 pounds of pesticide to 12 gallons of water. We live in a farming community. I think we understand that. Out there in the crops, pesticides keep all the pests away from ruining your crops, right? Could you imagine if you were going to mix your pesticides and you've got all these crops, you know, like tens of thousands of dollars worth of stuff, and you mix it too strong? What would happen to your crops if you mixed your chemicals too strong? They would die. What if you mixed it too weak? They wouldn't kill all the bugs and stuff. So we got to get the right mixture on this, right? So here we go. Let's do it. Do they give you a rate? Yes or no? Cool. Write that as a fraction with labels. And here's my question. Would this work? 12 gallons over 5 pounds. Or does it have to be 5 pounds over 12 gallons? Or maybe some people did 5 pest over 12 water. Like, I don't care what the labels are, literally, you know, like, but can I do 12 gallons over 5 pounds? The answer is yes, as long as the other one is gallons over pounds, right? Gallons over pounds has to equal gallons over pounds, but I'm not going to do it that way. I like to do it the way they listed it. Isn't it 5 pounds of pesticide for every 12 gallons of water? The point of a proportion is, as long as you get things lined up proportionally, it's going to work either which way. So it doesn't matter. So if this is pounds over gallons, that one's going to be pounds over gallons. Yeah. And we know, where should this 240 go? Next to gallons. Right there, next to gallons. So solve by cross multiplication. A lot of people end up forgetting about x when they do all this. You know, it's like, don't forget there's an x in there. 1,200 divided by 12, last I checked, was 100. And then be more specific with your label. What is the 100 about? That. Not just pounds, but pounds of what? Pounds of pesticide. How do you feel about that? Not bad? Mixture problem. Proportional, very nice with chemicals. And the most popular place you'll probably see it is with food recipes. You know that if you don't mix some of your food recipes up right, it tastes really bad, or it's just over salty or something like that. So let's see if you and a neighbor can set up a proper proportion. You can change the fractions to decimals if you would like. Right. I did 0.25 for the 1/4 and 3 for 3. What do you want to use for labels? We could have different things. What could we do for 0.25? What could be a label on that? Cups is fine. What else could be fine? Vanilla, which I'll abbreviate like van, you know, like vanilla. You know, either cups or vanilla. Makes perfect sense, right? You know? And downstairs, the label's pretty basic. Wouldn't you do eggs? Try to stay away from using one-letter abbreviations. Like if you did 0.25V over 3E, algebraically, you're going to get confused later because don't we have a lot of letters in algebra also? So putting like eggs is better than E. You know what I'm saying? So cool. And then, hey, if this one's vanilla over eggs, what does this one got to be? Vanilla over eggs. And then I got 60 eggs. Don't know how much vanilla. Again, if your labels were different, it's okay, right? You know, cups over eggs is the same concept, right? So, and then multiplying, what is that? 15 vanilla, I don't need a vanilla there. 15 equals 3x. So x equals what, baby? 5 what? Cups of vanilla. What do you think? Proportions. 2 fractions equal to each other. Solved by cross multiplication. Let us know if you have any questions. Have a good one.